Hey, welcome to another video. Today we are going to look into some code that was generated by Claude with Cursor and a couple of pretty good prompts of myself. We are not going to dive into everything, but we will just see what LLM can do and what it cannot do, since I'm finally finding some really obvious limitation. I have a lot of thoughts about how LLMs are working and what they can generate. Like there is all this vibe coding going around, but to be honest, I'm finding out that yeah, LLMs can actually generate quite a lot of things, and Cursor became really good at producing stuff. But unfortunately, it is not necessarily going to give us what we need or what we want. So when we are happy with getting something that is somewhere around what we actually are wanting to achieve and looks more or less like something we want, and this is enough for us, then actually these tools can create quite complex applications in mobile space, in web space, and probably in other spaces as well, without actually understanding what the applications really do under the hood, or understanding the code, or having to write a single line of code. For example, I have generated a whole new portfolio of mine, which is perfect, beautiful React application written by Lovable plus Cursor together with some Gemini outputs, and everything is deployed and working, and people are happy with it because it's beautiful. The thing is that it was just such a simple job and such a non-customizable thing that I could do. So based on the prompts, it just generated something that looked okay, and I was satisfied with it. So I used it, and everyone is happy because this is good enough. But it's also a super simple thing to do, which I could never force myself to do myself before. And yet, 4 hours, I have a new portfolio. Perfect. Okay, coming back to this code, what I wanted to achieve is this. So think of a graph, or actually not a graph, of a tree. It's not a binary tree, so we can actually have more. It's actually not even a tree when I think about it right now. Let's add another node here and here, because I think we could also draw that and that and that, and I'm still happy with it. And that's a graph, not a tree, although it's a directed graph. Directional graph, because I also can now go from this node to this. Okay, that looks really bad. The app actually renders it better and actually renders. So Claude actually achieved what I wanted, except it doesn't look like I wanted, but that's not something I can simply get out of LLMs. Okay, let's make it nicer. Yeah. But basically, I want to draw a graph or a tree from a graph theory that's as simple as that. Not a tree. Let's stop talking about a tree. It's a graph. Okay, so this is the code. It was generated by Claude 3.7 thinking model with Cursor, with a couple of different prompts which went pretty far away, and I'm generally happy what I have generated because I have something to start working with. However, it's far from perfect. It's far from what I wanted to achieve. But the cool thing is that I asked it to do it with Flame in Flutter, and it actually could do it with Flame in Flutter to a certain extent. So if you have never looked into Flame, this is like a library to draw things. Flame, Flutter, to make games or draw something on a canvas with having a little bit more control over how things are drawn, because we can use custom painter on a widget, but that's just a very basic UI. We cannot... if we want to make a game with this will be very daunting. It's like using the very old APIs in C++ when I was writing games in C++ like 15 years ago, doing everything myself, drawing on a canvas, making all the calculations. Was fun that time, but also it's just a very inefficient way to do. And Flame helps you with that a little bit. So what they state is that it's a modular Flutter game engine that provides a complex set out-of-the-way solutions for games. Exactly. So not only drawing, but also for audio and so on. So all of that is in this framework. Also, there is experimental 3D option, but we are not going to look into that because I think you can't even really use it in production right now. I mean, you could, but it depends on something called Flutter GPU, and this is another experimental thing coming from the Flutter itself. So if we look into here, let's skip all the Flutter-related widgets because that's not part of what I want to talk in this video. Instead, let's have a look into the game itself. So here we have a Flame game. Flame game is like the basic building blocks for having utilizing Flame for doing anything, basically, for drawing anything, for having games that could be interactable, of course. Then we have this scale detector and tap detector on it, so this is going to give us some callbacks when some actions are happening. We will see that in a moment. So what the LLM was doing, it was consistently also generating here a pan detector. Now, pan detector is good when we want to move left, right, top, and so on. And we get callbacks for that, but the problem is that it doesn't work together with scale detector, because scale detector is a superset of pan detector, and we are supposed to only use scale detector, and that's clearly set here in the documentation over here. Yeah, so scale is superset of pan, and we are supposed to use scale and not together with pan, and they are saying that in this case, when we are doing that, we are getting an assertion, and not only an assertion, but actually it doesn't work, was what I found. And I've tried actually to generate this code four times. Each time it was doing the same mistake, and each time I had to solve this mistake myself. When we talk about these different iterations of actually generating this code, I also wanted to add on top a layer where a user can actually draw something. So if we have these, what are they called? Nodes over here, I also want to have an option that someone can come and can just draw. How can I draw here? Yeah, whatever. Can be a line on top. So 2 times it actually did it kind of correctly. What I mean by that is that it generated the extra layer inside of the game, but 1 time it went crazy and generated a widget on top of everything, and this widget then would be a Flutter custom painter with another widget, and it wouldn't have anything to do with the game. And the whole idea was to have the drawing in a game, so then I can save it to the database and then reload it when the app is restarting, or even save it to some remote database and share with other users. But nope, it just completely went crazy. It created a complete new layer on top of the game and the drawing there, and that was crazy. Another time when I was trying to generate it, I also asked it to generate toolbox, so a user can choose a color with which they want to draw. So it struggled with that, so there was plenty of problems that were very hard to solve, and the whole app was crashing almost. Completely didn't work. So finally I have it generated in the way that is kind of usable, but I still have to fix, because it's a drawing below where I want it now. This is now resetting every time I turn on and off drawing, and then also it moves the whole canvas, so it looks like the whole game is being reset actually when I start or stop drawing, and I cannot draw many things. I can only draw 1 line. When I start drawing new line, then it resets again. So unfortunately, there is plenty of work for me to do right now to fix what LLM actually couldn't achieve, despite very detailed commands that or prompts that I gave it, including that I actually pointed where it should implement different things. So that's more or less what I want to my point with this video, that where are we with the whole vibe coding or whatever it's called. And actually there is a lot of things that can be done, and I'm starting to find a lot of limitation for the things that cannot be done with it yet, at least. And also I want to make the point again that whatever it gives you, it's not going to be exactly the way that we want it, and there is a lot of adjustments that need to be made later, how things look and so on. But quickly we can have a look. The code that actually generated is not too bad at all, so it's not adding like a ton of extra unnecessary things. So we have the flame game with detectors. We are getting the skill tree, which will have skills. We have some callbacks to return. We are also having the flag to say, okay, is drawing enabled or not? So this is what I'm going to have to work on it. Then we have zoom, maximum, minimum. Makes sense. We don't want to zoom out too far. It's of course going to be pitch to zoom, so 2 fingers and getting them closer or farther from each other. Then we have also the is drawing flag. So if it's drawing, then probably we should stop using other gestures, or to for example move the whole canvas, etc. when we are currently drawing, because then drawing will not work when the whole canvas will start moving as well. So this is what this flag is for. And then we have typical things from the game, from Flame game. So when the game is loaded, we need to initialize everything, and we are adding components to the game. So I'm not going to explain how Flame works in this video. That there is plenty of better ways to figure out that. But basically Flame game contains components, and components are like smaller parts on the screen. So when we have our graph over here, so each edge here, for example, and each node, the circle could be a single component. This is up to you to define how the components will look like and how granular they are, depending on what your needs. So when you need to move, for example, half of a circle, let's say that you decided, okay, you draw a line over here and now this splits the circle, so probably we need two components in order to be able to just move this part of the circle somewhere else, but this is not my case, so I'm not doing that. And also did not generate this kind of stuff. Okay. So here we have a drawing layer, so that's exactly the thing that I have to fix myself. And below we have the update loop. Yeah, like in any game system, we have two loops. We have update and render loop, and update loop is where we are doing all the logical updates, and render is just taking care of rendering the next frame. So that's how games are constructed, all of the games. Then we have, we are taking care of the camera. We are generating some background grid. I didn't even ask it to do that, but it did it anyway. Actually, I like the look, so maybe I will keep it. I need to update the background how it looks like, but I might keep the grid because it actually looks pretty cool. Then we have the update skill tree, and we also get the callbacks. Yeah, finally. Okay, these are the callbacks. So this is what happens when we have scale, start, update, and stop. So before, when it was generating also the extra detector for pan, then it would add more callbacks over here and everything. It just stops working. It didn't work correctly anymore. Okay, so it generated the game. It looks pretty good. There is only a couple of things that I had to change to it. Here is the grid that I was talking about. Again, nothing really crazy going on here. So we just have a paint inside of the render loop here. Yeah, look. So how Flame works is the Flame game has its own render loop, and then it iterates over all the components, and the components can be a tree-like structure. So components can contain components as well. Depends on the type of a component, of course, and then based off that, it will just go render into all of the structures. So it will traverse the whole tree and call all the renders on each frame. This is how this works. So we have a paint, we take care of the camera position here, and then we just, generate a grid. So all we have to do is just horizontal and vertical lines, and that's how the grid is rendered, that's all. So now here we have the node. So a node is the circle, and then we also have, except of the node, edge. So let's open the edge here. You can see the difference also that it used. So here we have a position component, and here we have a component which is like a base thing. Position is a thing, a component that has a little bit more capability. So we can see the documentation over here. A component implements that implementation that represents an object that can be freely moved around on the screen, rotated and scaled. So the thing about the component position is that it has a certain position, and then we don't have to care about where exactly should we put it on the canvas. So when we are drawing the grid, then we are taking the whole canvas, for example. Can we go back to the grid? Let's do this. Yeah, so it's also a position component, and you can see we get some size. Here we actually give it a huge size, which also means that it's not going to be drawn everywhere. Actually, that's something I might have to look into. That's a good question. Do I have a limited size of a canvas that it gave me? Maybe. I'll check that later. For now, let's talk about the skill nodes. So we have a size, we have a position. That's the position on the whole canvas on the game, and when we have all of that defined, then we don't have to take care later about offsetting all our calculations when we are drawing something. So when we are drawing something in the render here in Flame, then we can just render within the small piece of a canvas, and we can just assume that nothing else exists. So we don't care about the whole world that exists. We just take care of the small piece of the world where we want to draw, and we define, okay, 0, 0 is here for us. So we can draw from 0, 0, and then all the calculations will be done over by Flame in order to position it correctly on the whole canvas for us, which is pretty neat. And actually, you can see that the LLM could generate this case pretty well. Also, we get the paints, we get some border for the circle, so we draw the circle. And then finally, also, we have an option to draw, what is it? Check path, what is it doing here? Let's figure that out. draw a small icon of a symbol inside a node. Oh, okay. So if a skill is completed or learned, so the circle should have a check mark. Ah, okay. So we're drawing a check mark and we are using a path. So probably what is happening here? X divided by 2. Okay, so we're in the center. Or no, that's actually above the center. Like, I'm actually not sure whether X is on the corner. Yeah, X will be on the corner. So, okay, so we actually take a center because we do go by 2 by 2, and then we subtract from X also minus half icon size. Which is probably defined somewhere, I don't know, where is it? Up here? Yeah? No? Wait a moment, where is the icon size defined? Oh, here. So it's just node radius, okay, 60% of node radius. Yeah, so then we are going to this point, and we are starting drawing the path from here. What do we do here? We divide now icon size by 6, and we subtract it from X, so we are going to left, and then we are adding something to Y, so we are going down. Yeah, so okay, we are actually making a kind of a check mark. So, and then another line, so because check mark has 2 lines, we are drawing a check mark, so then we are just draw the path, we are using some paint to color it, that's it. And if this skill is unlocked, what does it do here? So we get a lock paint, lock rect, and also an arch. Oh, okay, that's actually pretty clever. So instead of drawing a PNG, it's drawing 2 shapes. It's drawing a rectangle and then it's drawing an arch, and it will look like a lock. Yeah, we could use a PNG, but PNG then we would have to go and draw every pixel. But when we have here just 2 shapes, basically, then we don't need to take care of every pixel, and this is a lot more performant than just drawing a PNG on the screen, on the game. And finally, we also have a callback. Yeah, so that's actually pretty clever. It's a good implementation. I'm really happy with how it looks like. And yeah, let's also have a look at the skill edge. I think this will be a bit more complex because, yeah, we need to have skill and target skill. So we have 2 skills, and then we are drawing the edge between the 2. So for example, from here to here. So we need to know position of this or this on the whole current canvas. So what are we doing here? We also have the render loop. Not much more magic because it's just a plain component, not a position component. What is it doing? Start and... Okay, so from here to here we have to paint it. It takes again XY of this and the XY of the target. Then it draws a line between other. Oh no, it takes a paint and then it defines the color based on some conditions. We don't care about that. And then it draws a line. Okay, so this is actually just a simple line to draw between the 2 points. That's okay. And then we have this huge function which is drawing the tip. Okay, because we still have a pointed arrow on top. So we are going from one node to another. I'm not going to go through this math, but I can tell you that this works. So actually the LLM was able to figure out the whole algorithm, how to nicely draw this line. Now I will not go through it because I just don't work with this kind of information. And I completely forgot. This is like a high school knowledge or maybe even lower knowledge, and I'm really ashamed to say, but I forgot how it worked. And if I would have to implement something like this before LLMs, I would need to go and I would need to research this first, find the correct equations, because what we have to do is we have to take this line, we have to then figure out how long we want to have these edges, and we have to figure out what's the angle. Yeah, so here between the line and between these 2 other lines that we have to, that are making the tip, we have to figure out what is the angle in proportion to this line. Also, we have to know how this line is also drawn on the whole canvas, so in which direction, and then we also have to figure out in which direction should the line be pointing, yeah, because it doesn't have to be from here to here, but from here to here. And then finally we have to figure out the point where we should start. So for example, we can start from the from this point, and then we can draw it to this point and this, or we can just draw one line from here to here and then the other side. What are they doing here? Arrow path. Okay, we just have one path. So yeah, which means basically that they drawing the whole thing with just one path. And somehow calculated it here. Yeah, okay, but that's well, that's not something difficult. I'm pretty sure you can find algorithms for that already ready on internet. So it's not like the LLM actually figured this out. It's nice though that it can output this code in something that is niche, right? Because Flame, Flutter combination for making graphics and drawings, I don't think that's something that you will get a lot of. I have done it once in past. So I worked with Flame to create like an app that would be taking MIDI signals through a MIDI channel from a keyboard, and then it would drawing nice effects on top of a piano. And yeah, that was a really cool project. I think somewhere on X there is still like a small video that I left, like my first post maybe, because, well, that wasn't my first post ever, because I just removed all my posts at some point because I wasn't sure if I want to go with X or Twitter anymore. But this one is staying there, so we can have a look. Flame is really good for these things, but yeah, I had a lot of fun generating this, and I'm going to continue working on this project and modifying this code, and also we try to continue using LLMs, but that's the experience that we have. And I still stand to my point that it's not possible to create something like this, like what I'm trying to create here, without having any knowledge or just prompting. And if even you actually will get the effect that you want to get, there is a lot of things that LLMs cannot do. For example, when I was trying to ask LLM to just take all this logic that it made and reverse everything, so the root would not be on top but on the bottom, yeah, I did not get it done. And I've tried a couple of times. I lost a lot of credits for this job, so it costed me, and I didn't get the job done. And I get it. It's not so simple, although I'm not 100% sure, because now we know that the skill edge is already capable of handling any basically start skill to target skill. So in theory, we could just like swap all the skill nodes, and then the edges, we don't have to do anything with that anymore. Hopefully this calculation is taking care of it. I don't know. It's something I will try to do myself maybe, and then we'll see how that works. But impressive. Yeah, this is really impressive. This is helpful. This makes my work easier, and I'm going to use it. But it's not going to give me what I want exactly. It's going to help me. The point I made earlier, that if I want something that I don't care how it looks, as long as it looks good, like my portfolio, yeah, with some cool animation, etc., we can just generate it. But if you're in a real company, in a environment when you have specific goals and things have to look the way they need to look, and they have to work the way we want them to work, because we know that if we make them work in a certain way, then we will generate more output, more revenue, then in this particular setup, LLMs still are only a help, and they are not going to replace us in the next couple of months, unless there will be a huge breakthrough, and then we will have to switch to the new breakthrough, and we will have to adapt to it and implement it into all our existing tools. So I still believe that we have a couple good months of coding in front of us, and with that note, I end this video because it's getting too long. Bye bye.